Hello, geometry class. This is Mr. Briggs. I'm going to take you on a little tutorial through CanFigureIt Geometry. This is an online tool we'll use to complete some proofs throughout the semester. I just think it's a little bit more interactive than writing down proofs out of the book, and I think it kind of helps you get more of a visual of what's going on in a proof, especially when we get into triangle proofs like this one that I'm going to show you guys. Uses side angle side eventually to prove that triangle ABD is congruent to triangle ACD. And you can see that when I go over this, it says prove, there's a target, that's what we want. And it kind of highlights the triangles. So it goes away when I, but you see how ACD, triangle ACD, is highlighted in yellow, and triangle ABD is also highlighted in yellow when I go over this. And I'm certain, yeah, it's the same when I go to the unjustified claim here. So our unjustified claim obviously is our angle. That's what we want to prove. Our justified claims, this list is going to get longer, but for right now it has our givens, and those are indicated by a present box because they're gifts, right? Yay, great. So if I go over that these are perpendicular, that segment AD is perpendicular to segment BC, highlights that over to the left in our model, just to give you a better visual what that's saying, what that means. And the same with this. Highlights the segment that it's talking about. That segment BD is congruent to segment CD. Alright, so let's get started with our proof. I notice that these two triangles share a side, so I'm going to go ahead and claim that segment AD is congruent to itself, and we can use the reflexive property to justify that. So I'm going to work on a new claim, choose the type of element. I can choose a point, a line, an angle, a triangle, a polygon, or a circle. Obviously we want to choose segment, because that's what we're dealing with. So I want to claim that it is congruent to itself, so I'm going to choose that, and I can either click on the actual segment AD, or I can type it in like so, AD. So I'm claiming that segment AD is congruent to segment AD. We're going to claim it. Yes, that's what I would like to claim, so I'm going to confirm it. So now we got to justify it with a theorem. We can't just say that it's congruent to itself, as I alluded to earlier. So we have a lot of theorems down here that could be useful. Like a rhombus is a quadrilateral with 4 congruent sides. I don't think that's useful here, but it could be in another proof, or even later in this proof, who knows. But just looking at the visuals for the theorems here, I'm going to take an educated guess and say that this is what we probably want to use, and it is. It's the reflexive property, that a segment is congruent to itself. So segment AD is the same as segment AD, and this arrow means implies. So the fact that this is true implies that this is also true, that segment AD is congruent to segment AD. It's kind of like an if-then statement. So if segment AD is the same as segment AD, then segment AD is congruent to segment AD. And this is true, so this is true. It's a classic if-then statement. So let's submit it, see if we got it right. Bingo! We got it. Alright, so I can see now that we have shown that segment AD is congruent to itself, that it turned yellow, and that it has the two little lines right there, segments, not lines. So now I'm going to take a little bit of a leap here. We're going to have to use one of these givens to move on now. And I don't think it really helps us. I mean, you can take it two directions. Either one will help you. I take that back. But I'm going to go ahead and use this first claim, that segment AD is perpendicular to segment BC. Why is that important? So perpendicular, what does that bring to mind? 90-degree angles, right? So I'm going to claim that something is a right angle. What do I want to claim is a right angle? Well, I think it'd be logical to say that either of these are right angles, wouldn't you say? So let's say it. Let's claim it. That angle CDA is a right angle. Claim. Confirm. That's what we want to claim, to justify. So we got our theorems that we could possibly use here. Theorems or postulates. I like this first one. It says perpendicular lines meet at a right angle. Let's use that. What's perpendicular? Well, it says what's perpendicular right there. And you can actually click on that right there because we've already justified it. It's been given to us. And it says segment AD is perpendicular to segment BC. So that means that angle CDA is a right angle. Let's submit it. That's correct. And similarly, we can do that with our other angle because it's true on both sides of segment AD. So let's justify that that angle is a right angle. Oop, it didn't let me. There we go. So angle ADB is a right angle. Let's claim it. Confirm that's what we want to justify. And we can use the same theorem. And also use our shortcut there. And by the same logic, that is a right angle as well. Ta-da! So, this is awesome. I love this. We got a nice visual here now. And we got a segment congruent to itself. We got two right angles that are corresponding. And we also got that segment BD is congruent to segment CD right here. And I think to myself, well, self, that's enough to prove that these triangles are congruent. So let's do it. And this is going to be a claim about a triangle, or triangles. So I'll click on a triangle, choose the claim, congruent triangles. Sweet, that's what we want. We want to, I was going to see if the shortcut worked to click on that, but it doesn't. So let's just copy it down from up there. We want to prove that triangle ABD is congruent to triangle ACD. Let's claim it. So that's our claim. They match. Let's confirm that. So let's justify it with a theorem. We could use hypotenuse leg. Well, we don't have that. Angle, angle, side. I don't see that we have two angles congruent, so I don't think that that applies here. Angle, side, angle. Again, I don't see two angles here. Side, side, side. Well, we have two sides that we've proven to be congruent, but we don't have that third side, AB, segment AB congruent to segment AC, so that doesn't apply either. So we got one last theorem we can use, which is side, angle, side. And it says if two sides and the included angle of one triangle are congruent to the corresponding parts of another triangle, triangles are congruent. And I see that here. We have two sides and the included angle, which means that the angle is between the two sides, and they're congruent to the two sides and the included angle of the other triangle, that those two triangles are congruent. So I like that. Let's try that. And we need to type in our corresponding sides and angle that are congruent to justify that the two triangles are congruent. So we have that BD is congruent to CD. We have that angle CDA is congruent to angle ADB. And it's giving me ABD. Oh, you need to write it in order. That's kind of a big thing. It doesn't like it when you do that. I'm sorry, guys. So, ABD. So yes, we want to use this and this. You want to correspond them to the triangle that they are part of. So be careful with that. And the sides that are congruent, AD is congruent to itself, like we proved earlier. So we have by side angle side that triangle ABD is congruent to triangle ACD. And we submit that, and it gives us a well done. We proved it. Great job, guys. I hope you found this useful. And if you have any more questions, don't be afraid to email me or ask me before or after class at any time. We will use this at times during the semester. I just think it's a fun tool, makes proofs a little bit more engaging, I guess, just they can be a little bit boring, I'll admit it. So I think this is a good tool. Alright, I will see you guys later.